All right, welcome. We're going to start with summation notation. This will be very important for our integration theory. Here we go. So, it's going to come up all the time that we have to write things like this. A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus, 100 other terms after that, where each of these A's are numbers. And it gets way too long to write this. So we came up with what's called summation notation, and it's done as follows. So this notation here, the sum from j equals 1 up to n of a sub j, means, so I'm telling you what that symbol means. It means start with a1 and then add a2 and then add a3 and add a4 and keep doing this until you get all the way up to a sub n. Okay? So this j here is acting sort of like a dummy variable. First you plug in j equals to 1, then you plug in j equals to 2 and add it, then you plug in j equals to 3 and add it, until you get to the very end, you plug in j equals to n and add that and stop. More generally, you don't have to start at 1. You can start at any number you feel like. You could start from m to n, and that means you start with j is equal to m, so you get a sub m, and then you start increasing it. You increase it j to m plus 1, and then to m plus 2, and so forth, and you stop when you get to the a sub n. Okay? That's summation notation. All right, let's do an example where it's a little bit explicit. Let's do the sum from j equals 1 up to 4 of j squared. So what you're supposed to do is start with j is equal to 1, plug it in there, so that's 1 squared, and then add it to, increment the j, so it becomes 2, plug it in there, so it's 2 squared, add it, now change the j to a 3, plug it in, 3 squared, change the j to the 4, 4 squared, and now that we've hit the top here, 4, we stop. You can add that up, and that's what the sum is. This j, by the way, is just like a dummy variable. You can switch it out to any letter you want, any symbol you can draw, in fact, so you could write the sum from k equals 1 up to 4 of j squared and of k squared, and you do the same thing. First you put k equals to 1 and plug it in, then you change it to 2, plug it in and add, change it to 3, plug it in and add, change it to 4, plug it in and add, and since you've hit the end, stop. Alright? Alright, let's do another example. The sum of 3k to the 5th plus k from k equals 1 up to 3. Well, first we start with k equals to 1, so that's 3 times 1 to the 5th plus 1. And then you have k equals to 2, and you plug it in and add. So that would be 3 times 2 to the 5th plus 2. And then you do k equals to 3, and we'll stop after that because that's the upper limit. And you plug it in, so that's 3 times 3 to the 5th plus 3. And you can add that on a calculator or by hand if you want and compress it, but that's all there is. You can also do this notation in reverse. So write this expression here in summation notation. Okay? Well, you can just read off what's happening here. You see each time you're keeping everything the same, except here you have 2's, here you have 3's, here you have 4's. So that's the part that's being changed. So it'll be the sum from j. It's starting at 2, we said, and it's going to stop at 4. And what you do is you just take 4 times that j value, you do its 7th power, and then 3 times just j all by itself. And that's the answer. All right, there are some properties that are good to know, and they really are pretty obvious. Since summation is just adding, it behaves just like addition. So the properties that we have are this, the sum from j, I'll do it from 1, but you could start anywhere, n, of aj plus bj would be the sum from j equals 1 up to n of aj plus the sum from j equals 1 to n of the bj's. So you just add the a's and b's together, or you could add them separately, same thing. And number 2, constants will pull out. If you have some constant c times aj from j equals 1 to n, well, that's just c times a1 plus c times a2 plus c times a3, etc. And you can factor a c out of everything, so the c just pulls out. All right, so that's it for summation notation. See ya.